Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today we are going to see about fuels. Let us see the introduction to fuels. So you must be all familiar with what a fuel is. In day-to-day life, we are using fuel for various purposes, cooking, then we use in vehicles and other things. Okay, so in this chapter, we are going to see about the introduction, characteristics of good fuels, classification of fuels, comparison of solid, liquid, and gaseous fuels. Okay, in the scientific term, fuel is a combustible substance. What is combustible substance? It can be burned, right? And containing carbon as the main constituent, which on burning gives large amount of heat. During the process of combustion, carbon, hydrogen, etc., combine with the oxygen with the liberation of heat. So we know different types of fuels: charcoal, liquefied petroleum gas, then kerosene petrol. So the calorific value of a fuel depends mainly on the amount of carbon and hydrogen. So the calorific value, that is carbon plus oxygen, they combine to give carbon dioxide plus 94 kilocalories of energy. Hydrogen plus oxygen gives H2O plus 68.5 kilocalories. So fossil fuels are those which have been derived from the fossil remains of the plants and animal life. They are there underneath the earth for the millions of years under the pressure and temperature to form the fuel. So the main source of fuel is coal and crude petroleum, which is found underneath deep in the earth's surface. So you know all conventional fossil fuels, whether it's a solid, liquid, or the gaseous, that is, for example, for the solid it's coal, liquid it's petroleum, and the gaseous fuel, for example, of the natural gases, they contain basically carbon and or oxygen. The fuels and combustion in the presence of oxygen in the air release heat and energy. So there are certain conditions for the fuel to be said as a good fuel. So there are requirements such as the fuel should have high calorific value, it should have moderate ignition temperature, low contents of non-combustible matters, the moisture content in the fuel should be very less, then the fuel must be free from objectionable and harmful gases like carbon monoxide, sulfur dioxide, hydrogen sulfide. Then the moderate velocity of combustion it should be there. Then combustion should be controllable, under control. Easy, it should be easy to transport and readily available at the low cost. When a fuel is said to be a good fuel, it should have these conditions which is discussed in this slide. So classification of fuels. Fuels are classified into following types based on occurrence. Okay, so this based on occurrence, it's classified as primary or natural fuels, and next is the secondary or artificial fuels. So primary fuels are nothing but it is found in nature, as we already saw the coal and the petroleum that is present in the underneath the earth, and the natural gas which is present above these, they are the natural fuels. Okay, so they are found in nature. And secondary or artificial fuels, these are derived from the primary fuels. Example, coke, gasoline. So coke, we get the coke from the coal. Gasoline we get from the it is an artificial form of petrol. Okay, so they are classified into another types based on the physical state. Okay, first we classified under the that is the occurrence, based on the occurrence, and next we are going to see how they are classified based on the physical state. So solid fuels, example coal, coke. Liquid fuels, example gasoline, diesel. Gaseous fuels, example coal gas, natural gas. So these are based on the physical state. Okay, so we will see the flow chart, that is fuels, They are classified as primary or natural fuels, secondary or artificial fuels. The primary or natural fuels, they are solid fuels, liquid fuels, and gaseous fuels. Example for the solid fuel is wood, coal. Liquid fuel, petroleum, oil. Gaseous fuel is natural gas. So these are primary or natural fuels. Secondary or artificial fuels, that is, again they are classified as a solid, liquid, and gaseous fuel. Example, coke and charcoal. And for liquid fuel, diesel and kerosene. And the gaseous fuel, coal gas, water gas. So now we'll see about a comparative study of solid, liquid, and gaseous fuels. So okay, first we'll see about the calorific value. The property is calorific value. For the solid fuel, due to air and the moisture content, calorific value is very low. Liquid fuel calorific value is higher than solid fuel, and the gaseous fuel, it has the highest calorific value than the solid and the liquid fuels. And the next property is the combustion. If the solid fuel, the combustion is slow, liquid it's quick, and the gaseous fuel it is rapid, that is it's very fast. Next is the property is the thermal efficiency. So solid fuel, it has the least thermal efficiency, liquid is quick, and gaseous fuel it is rapid. And next is the ignition temperature. When we compare the ignition temperature of the solid fuel with that of the liquid fuel, it has the highest ignition temperature than the liquid fuel, which is moderate, and the gaseous fuel, which has the low ignition temperature. And the next property is the cost of production. So solid fuel, the cost production is low compared to that of the liquid fuel, which is high, and the gaseous fuel is high as well. Next is the pollution. So when you compare the pollution studies of solid, liquid, and gaseous fuel, the solid fuel will exhibit large amount of pollution, like they release smoke, dust, and soot particles, and the liquid fuels clean and free from dust and other particles. Gaseous fuels, they clean, and no smoke or dust particles are liberated by burning up the gaseous fuels. Next is the property is the fire hazard. Okay, solid fuel has the least risk. Liquid fuel, it is more riskier than the solid one. And the gaseous fuel, it's highly inflammable and it is mostly risky. Thank you.